In this lesson, you will learn to express a given proportion in an equivalent form. Now to begin, we first need to define the term proportion. A proportion is an equation stating that two ratios are equal. So ratio can be written as a fraction. So if we have two fractions that are equal, then that's going to be a proportion. So here we see 4/8 equals 1/2. This is a proportion because we have two ratios that are set equal to each other. Now with proportions, let's say we had 2/4 equals 1/2. There are different properties that we can use. The first one is that we can take the numerator and denominator and switch them. So instead of 2/4, I can have 4/2. And instead of 1/2, I would have 2/1. So what I can say is that 4/2 equals 2/1. And notice that would be a true statement. We could change the numerator and denominator for both fractions and get an equivalent expression. Property 2 says that I can take the numerators and make a ratio with the numerators. So 2 and the 1 make a ratio with those. So now I have 2/1. And then make a ratio with the denominators. So I have 4/2. So I can say 2/1 equals 4/2. And notice that would be a true statement. 2/1 would be the reduced form of 4/2. The third property is not very intuitive. But let me explain to you what the third property says. The third property says if I take the original ratios, so 2/4 and then the 1/2. And what I can do is then for the first ratio, the denominator is a 4, so I can add 4 to the numerator. And then over here, the denominator is a 2, so I can add 2 to this numerator. And this would be an equivalent expression, where now I would have 6/4 equals 3/2. And notice that would be a true statement. 6/4 could reduce to 3/2. So that is your third property. You can add the denominator to the numerator and do that for both ratios. The fourth property is what we often call cross-multiplying, which says that if I take the 4, multiply it with the 1, that would equal 2 times 2. So I'm multiplying across 4 times 1 and then 2 times 2. And notice that would be a true statement. 2 times 2 is 4, and that would equal 4 times 1, which is also 4. So here we have 4 properties that we can use with proportions. And the main one that you definitely need to know is this fourth property. You will see this very often, and as we move on in the chapter, we will use the property 4 more than the other properties. Let me go through some example problems using these 4 properties, and I will focus in at the end on cross-multiplying. So here's another example, where we have 4/12 equals 2/6. That is a true statement because 4/12, you can divide the top and the bottom by 2 to get 2/6. So this is a true statement, and the first question would be, 12/4 would equal what over what? So looking at the proportion, we are flipping the numerator and denominator. So instead of 4/12, we have 12/4. So for the other ratio, I can flip the numerator and denominator as well to, instead of having 2/6, I would now have 6/2. The second one, we have 12/6 equaling something over something. So notice what I'm doing. I'm taking the 12 and then dividing it by the 6. Well, I can do the same thing for the numerators, where I take the 4 and divide it by the 2. So 12/6 would equal 4/2. And then lastly, we have 16/12 equals something over something. This one is using the third property, which is not quite as intuitive. But notice that we are taking this first fraction, the 4/12, and we are adding a 12 to the numerator. So now we have 16/12. Well, for the other ratio, I need to do the same thing, where I had a 2 over 6, but now I need to add this denominator as well. So now I have 2 plus 6 over 6. So that would give me 8 over 6 for the other ratio. So that would be my answer for the second one. 16 over 12 would equal 8 over 6. Now looking at the fourth property, cross multiplying. Here we can use cross multiplying to solve equations, where if we don't know a given variable, we can find what that is. So using cross multiplying, I would take the 5 times the x, and then set that equal to 2 times 3. So I have 5x equals 2 times 3. And 2 times 3 is 6, 5 times x is 5x. And I can solve this for x by simply dividing both sides by 5. Where now I have x equals 6 over 5. Here's another example, where now I have more than one term on the numerator and denominator, but I can still solve this by cross multiplying. So I take the 2x plus 1, multiply it by the 3, and then take the 2, multiply it by 4x minus 1. So I get this expression, and now I need to solve for x. Well, this uses algebra, where I simply distribute the 3 times the 2x, 3 times 1, and then 2 times 4x, and then 2 times negative 1. So now I have 6x plus 3 equals 8x minus 2. And then to get x by itself, I need to get rid of either negative 2 or the 3 and move it to one side. So I'm going to move the negative 2 to the left side. You could do the other way, where you bring the 3 to the right side. Either is fine. You just want to bring these numbers together somehow. So I add 2 to both sides. Now I have 6x plus 5 equals 8x. And then I need x to be on the same side. So I can bring the 6x over with the 8x. Or I could go the other way, bring the 8x over to the 6x. Either is fine. But here I'm left with 5 equals 2x. So then to solve for x, I can divide both sides by 2. And now I have x equals 5 over 2. And that concludes our lesson for today. We will see you next time.